Hey guys, in this video we're going to get into section 6.7 and we're going to be talking more about graphs of polynomials. So the big things we want to know from the polynomial are its leading coefficient, which is that a term when it's in standard form. And then n is our degree, right? When it's in standard form, it's that highest exponent that we see, and then all the other exponents go down from there. And then e in this case, just from this example, but that constant on the end is our y-intercept, right? The one that doesn't have a variable with it. All right, so one thing that we haven't talked about is we've seen these polynomials kind of turn throughout, and there is kind of a rule for that. So whatever the degree is, the number of turns is one less than that. So if it's a fourth degree, it can have at most 3 turns. Now, if it has complex roots, it will have less than that, but this is something that can help us determine what the smallest degree could be. So the maximum number of turns is only 1 less than the degree. The ends of the graphs also can vary. They can be pointing the same direction, opposite directions, both up, both down, left to right, opposite. So lots of different options. Well, actually, I shouldn't say lots. There's 4 different options, but we can actually tell what it's supposed to do from the leading coefficient and its degree. So here's kind of our chart we're going to rely on for that. So if A is positive, the right side of the graph is going to go up, okay? If A is negative, the right side of the graph is going to go down. So if it's an odd degree, the ends are opposite, and if it's an even degree, the ends are going the same way. So paired together, positive odd is going to look like this, okay? Right side going up, but the ends are opposite. Positive even, right side going up, but the ends are going the same way, okay? Negative odd, negative even. Now, this notation in these boxes, you guys, is how we describe end behavior. This is how you read this. As x approaches positive infinity, p of x approaches positive infinity. So what that is saying, as x approaches positive infinity, that's saying about the right side of the graph. So it's saying on the right side of the graph, p of x goes up to positive infinity. As x approaches negative infinity, so x is negative infinity on the left, so it's saying on the left side of the graph, p of x goes down to negative infinity. So this is the proper notation for writing end behavior. So these are the ones that match these particular graphs. We're going to practice doing that on our own here. Okay, so what we're going to determine, you guys, is we're going to determine what the end behavior is and the maximum number of turns, okay? So this is a third degree, and our leading coefficient is negative 1/3, okay? So it has a negative leading coefficient and an odd degree. So negative means the left side's going, or excuse me, the right side is going down, and an odd degree means the ends are opposite. So these are what my ends look like, okay? If it's a third degree, max number of turns is 2. Okay, so that means like 1, 2. So there's 2 different times where it changes direction in the middle, okay? Don't know if that's exactly what it looks like, but that's what it could look like based on this information, okay? So what is the end behavior, okay? So on the left side, that's as x approaches negative infinity, okay? So here's what we're going to write. As x approaches negative infinity, f of x, that's this function, I want to know, is it going up or down? So on the left side, it's going up. So if it's going up, it's going to positive infinity. Okay, if it were going down, it would go to negative infinity. Now we're going to talk about the right side. As x approaches positive infinity, so that's the right side of the graph, what is f of x doing? Well, the graph is going down on the right side, so it's approaching negative infinity. So this is how we write end behavior. So that is what we are talking about when it asks for end behavior, but a sketch can really help you come up with this. Okay, we're going to do the same thing on this next one. So my degree here is 4. My leading coefficient is positive 3. So I can have a max number of 3 turns And we know it's an even degree, so it's going up on the right side, and it's a positive leading coefficient, so even degree, sorry, I switched that. Even degree, they're going the same direction, and positive leading coefficient means right side's going up. So it looks like this, and I can have 3 turns in the middle. So 1, 2, 3, something like that, okay? All right, so end behavior on the left. So as x approaches negative infinity, f of x is going up to positive infinity. On the right side, so x approaching positive infinity, the right side is also going up. So also positive infinity, okay? All right, here we're looking at some graphs, and it says, given the graph, identify if the degree of the function is even or odd, and if it has a positive or negative leading coefficient. Also identify the smallest possible degree. All right, so the degree, we want to know even or odd. Okay, well, if the ends are going in opposite directions, the degree must be odd. Leading coefficient, okay, well, if it's negative, remember it's going down on the right, and if it's positive, it's going up. This one is going down on the right, so it has to be negative. Now we want to look at turns. So this one has 1, 2 turns, it looks like. So the smallest degree it could be would be 3. And it must be odd, and 3 is odd. All right. Here, my degree, the ends are going in the same direction, so my degree must be even. My leading coefficient, the right side is going up, so it is positive. Number of turns. All right, so we have 1, 2, 3. So smallest degree it could be would be a 4. All right, and that's all for this video, guys. Thanks for watching.